All right, cool. So, hello. Thanks everyone for joining the first talk of the day. Really appreciate you all coming in. My name's Dom, and as mentioned, I'm one of the co-founders at Bob. We are building what we call a hybrid L2. That might be very confusing, so I'm going to talk today about what that actually means, why that matters, and how we're doing this. Why bother with Bitcoin in the first place, right? We're at an Ethereum conference. Why do I talk about Bitcoin? So Bitcoin is the largest asset class. Even if you take, all of Ethereum and all of Solana and you combine it, then Bitcoin is still so much larger. And we think basically there's a huge gap in the way that Bitcoin is used right now. So you have like 30% of Ethereum's TVL that's like on-chain. But in Bitcoin, the on-chain TVL is just 0.3% of all the Bitcoin that actually exists. And if we can, grow that to the 30% of on-chain TVL that Ethereum has, well, we have a huge additional market opportunity there. And really, if we think about why we're all in, cryptocurrencies, Web3, if all we ever do is use Bitcoin on Revolut and Robinhood and Coinbase and Binance, then why even bother with cryptocurrencies in the first place? So really, we want to get this on-chain, and we think it's a huge opportunity for everyone to do that. One of the reasons we haven't really seen much of on-chain movement on Bitcoin, in our opinion, is Bitcoin is really good at focusing on mass adoption. So getting more users, running big conferences, getting ETFs approved, but a lot of the talent and users and the capital for innovation actually moved over to Ethereum mostly and to Solana as well, and the L2s, Arbitrum, Optimism Base, because on the technical side, like most of the innovation in the past years all happened on this side. SocialFi happened here, AMMs happened on Ethereum. So there's a big gap between what Bitcoin can do right now and what we have over here. So why is that? We think there's three main challenges to actually build a Bitcoin L2 and to bring this innovation back to Bitcoin or combine Bitcoin and Ethereum. You have a Bitcoin security and bridge problem, so that's a very hard technical problem. Like, how do you actually get Bitcoin security and how do you build a secure bridge? Pretty much all the bridges we have right now for Bitcoin are centralized, wrapped-BTC, CBBTC, is a few trusted entities. And Bitcoin security, yeah, you can do some anchoring techniques and stuff like that, but it's a tricky problem. The other two problems are equally important in our opinion. You need to build up an ecosystem. You need to have users. You need to have apps. You need to have interesting applications. And I think this is where a lot of the current L2s also fall short. It's more or less copycat applications of existing Ethereum L2s. Right now, probably, if you look at innovation, on Solana it happens. A lot of people deploy on Base and on Arbitrum, but there's very little novel applications being deployed actually on Bitcoin L2s. And last but not least, you need liquidity, especially if you want to do DeFi. Your users want to have low slippage. They want to have efficient trading routes, and for that you need liquidity. So you need to solve all of these three problems. And how we are approaching this is, and now I'm talking mostly about the first problem actually, so today mostly here. I'm not going to spend much time on ecosystem liquidity. How we're solving this is we taking the OP stack, so we get standard EVM, we get a Ethereum native bridge. We adding rollup security via ZK verification using RISC-0. So RISC-0 is working on the Kailua project. We are one of the first rollups to actually implement that into production. It's on testnet right now. And then on the Bitcoin side, we need finality anchored into Bitcoin. This is where we're working together with Babylon to integrate Bitcoin staking. And then the big thing that I'm going to talk about today is native Bitcoin bridge via BitVM2. BitVM2 is like a new technology that allows us to do fraud proofs on Bitcoin. And with that, we can build Bitcoin bridges that don't have a majority assumption, but you just need one single honest party to make sure that the bridge is actually correct. And very last thing is this Bitcoin access via Bob Gateway. That's our Bitcoin intents bridge. Not going to talk much about that today, but there's some interesting work that we're doing with that as well. So if you're familiar with like across or similar intent-based bridges, we basically do that with Bitcoin. All right, so going to talk about hybrid architecture first, like how does it look high level. Then going to talk about BitVM and then how kind of this whole Bitcoin staking actually fits into that. So we're going to go from our OP-Stack rollup. So those of you familiar with OP-Stack, you have a sequencer. It produces blocks every 2 seconds, and that's pretty standard. You have a native L1, L2 bridge, where you have Ethereum security, basically, via fraud proofs. And currently on Bob, you have all the wrapped Bitcoin assets that you already have on Ethereum, like wrapped BTC, TBTC, and the different Babylon LSTs, like Xsolve BTC or LBTC. The cool, interesting thing is you can get them with a single Bitcoin transaction on Bob via this gateway construction. Yeah, just as a side note. Now, what we're doing with the OP-Stack, so we're leaving the core component, like produce blocks every 2 seconds. That stays the same. Now what we're adding is Bitcoin finality. So as you know, like OP-Stacks, they finalize on Ethereum, and it's basically you have a state proposal, and if nobody challenges it within a timeout period, usually 7 days, then it's considered final. That's pretty slow to finalize. If you ever had to withdraw from Base or Arbitrum, waiting for 7 days for your assets is no fun. So with Babylon, we can do Bitcoin staking, which allows us to finalize the state of the rollup much faster, but it doesn't impact safety, because for safety, we are still using a validity proof over block that we verify on Ethereum. So you get fast finality, but you still get the safety guarantees on Ethereum. And then how we get the native bridge to Bitcoin is via this BitVM construction, which I'm going to talk about in more detail. And then lastly, if we ever get to that stage, we can also get Bitcoin security as like a proper rollup on Bitcoin. This is early research. Oh yeah, the previous one, that's on testnet, and first one is actually live right now. The last one, that will be constructing a full rollup. Biggest problem, or one of the biggest problems here right now is if you want to do a proper rollup, you want to have the data availability on Bitcoin as well. Bitcoin has very little storage capacity, so it's very expensive to do that. So right now that's not really possible unless you want your users to pay a lot of money for your chain. So this is in very much R&D stage. Okay, cool. Let's dive into BitVM. I think BitVM is an interesting topic. Who has heard about BitVM before? Most people. Oh, that's a lot more than usual. Cool. Awesome. So yeah, most of Bitcoin Bridge is centralized right now. This is from bitcoinlayers.org. They're like a L2 beat for Bitcoin-ish. And yeah, as you can see, like RapBTC, Binance, like those are the big Bitcoins right now. Pretty much none of these are decentralized. And we think like one of the big issues well, why would you go on-chain and not use Coinbase, Binance, or one of these other providers if you go take your Bitcoin on-chain, it's anyway centralized, so might as well just stick with a centralized application, right? So somehow we need to change this. And you have the standard bridges, so you basically trust the majority of the signers that is correct. So for RapBTC, you trust BitGo and Tron. For CBBTC, you're trusting Coinbase. TBTC is a bit better in that sense. You still trust the majority, but there's like a more open signer set, and there's way more signers in this. But the cool thing with BitVM is basically it's very much like an optimistic rollup. You have fraud proofs, so you just need one honest challenger. And the bonus with BitVM is you can actually go and verify it yourself. So if you're very technically capable, you know how to run infrastructure, or you trust somebody who can do that, they can actually verify that it's correct, and it's all done via ZK proof. So not a signer set, you can actually disprove somebody or prove that somebody behaved correctly or incorrectly, which we couldn't do before. So how does BitVM work? So in a very, very simple initial construction, you have a thing called operators, and operators are the ones that operate the bridge. They have a wallet on Bitcoin, and they set up this BitVM program. We're going to treat the BitVM program as a black box for now. BitVM program under the hood, it's a bunch of Bitcoin transactions, but yeah, so the operators set up an instance of this program, and they facilitate this bridging process. Technically, anyone can be an operator. The BitVM program implements like the bridge. You can implement any kind of program in BitVM, but in our case, because we talk about bridges here, we are implementing basically a light client for the Bob chain. And yeah, under the hood is a bunch of Bitcoin transactions. And then we have another role. The committee, they sign and verify BitVM programs. The committee is mostly a workaround for a limitation in Bitcoin script. You're going to hear me say that quite often. Bitcoin script is very limited of what we can do. If we had covenants on Bitcoin, we wouldn't really need the committee, but we don't have that, so we need a committee. And they're really just there to verify that the program is correctly, and they are handling the connections between the transactions. So what a user now does, they lock Bitcoin with the BitVM program, and then that's more or less a normal Bitcoin transaction. And then the operator would do an SPV proof on the Bob side, so Bitcoin light client on the Bob side into the bridge contract, and then you would admit BitVM, BTC, ERC20 on the Bob side, and then you have a fully fungible wrapped Bitcoin on the Bob side that you can use on any chain. Since Bob is a ETH rollup, you can then use it on anywhere on Ethereum, really. Bob is also part of the Optimism superchain, so you could move that anywhere you really want to. And then that's basically it. Like for the users, just these two steps. And then if you want to go back, this is where it gets interesting. So the user would lock their ERC20 on the Bob side and burn it. The operator, this is the important part, they send Bitcoin to the user. They see that the Bitcoin has been, the ERC20 was locked and burned. And then the operator prepays to the user. So the initial Bitcoin is still locked in this BitVM program, and now the operator sends the Bitcoin back to the user, and now they need to claim it back. And this claiming back logic is precisely where the fraud proofs come in. So operator sends a proof to the BitVM program saying, okay, I sent Bitcoin to the user, and the bridge Bitcoin has been burned. And then the challengers, they verify that that was actually done correctly. So you have like a challenger role, like in the fraud proof, that says, wait a minute, did you actually send the Bitcoin to the user? Was that a correct address? Was it actually correctly burned? And because that's a ZK proof, we can prove that. So that is very high level how the bridge works, and now let's dive a tad bit deeper. So that BitVM program for Bob implements basically more or less 5 conditions. So we need to burn the BitVM BTC on Bob. We need to make sure that the Bob blocks are actually correctly produced. We need to make sure that those are signed, aka finalized, that it's checkpointed onto Bitcoin, so we know that the finalization is actually more or less irrevocable, because if it's deep enough in Bitcoin, like it's really expensive to actually change it. And then making sure that the packout transaction is on the when the operator sent the Bitcoin to the user, that it's on the same Bitcoin chain as the Bob checkpoint on Bitcoin. So we make sure that we stay on the same chain. And now this is the most complicated slide, but it's also the most fun for the ones that are technical. Right, so this BitVM program, right? So the 5 things that we very simply wanted to do, we encode this into a program, a prover, and then we have a snark verifier. The cool part in BitVM, this snark verifier, we actually implement this in Bitcoin script. Yes, it's possible to do this in Bitcoin script. It's very large. Right now, I think it's actually down to about 1 gigabyte. So it's not 2 gigabytes anymore, but it's a very, very large program. now people that know what's going on in Bitcoin, they're like, wait a minute, Bitcoin blocks are at most 4 megabytes big. How are you going to fit like a huge program like that onto the Bitcoin chain? Well, you don't, so you need to do a little trick. And the trick is we're splitting up this verifier in Bitcoin script into a lot smaller chunks that are maximum 4 megabytes big. And these chunks, we take a program, we have one input here, and now what we do, we chunk it up, and we take the initial input as the initial input here, and then we take the output of this 4 megabyte program as an input to the next one, and the next one, and the next one, and the next one. And that way, we can now include part of the ZK verifier onto Bitcoin. Now, what happens? So our operator now, in this step, the operator submitted to this program the ZK proof saying that they did all of these things, and these are true. If this isn't true, what the challenger actually does is the challenger is going to look at the ZK proof, going to do the same kind of construction and splitting up, and then the verifier is going to say, wait a minute, your proof is actually wrong, and it's wrong in this part, or it's wrong in this part of the verifier construction. And then the challenger is actually going to tell the operator, look, you actually need to prove to me on-chain that this is correct. Now submit this part on-chain to Bitcoin, and we're actually going to verify, we're going to execute this part of the snark verifier in Bitcoin script on Bitcoin. And with that, we get full Bitcoin security of the verification of the program. So we're doing a bisection over a ZK verifier, and then execute it in Bitcoin script on Bitcoin, and that way we get to do fraud proofs on Bitcoin. I know this is all very technical, and I'm skipping over a lot of more nuanced details. How do you get the data? There's some winternets and Lamport signature commitments, but yeah, happy to answer that and a few follow-up questions. Yeah, and you basically, once you're done with the challenging, so you can verify it actually on-chain on Bitcoin because it's in script, and that way you can know that the bridging is correct or not. And if the claim by the operator was incorrect, you just slash the operator and you don't release the Bitcoin from the BitVM instance. Another operator can come in and do a correct proof and then claim the Bitcoin back. So as long as you have online honest operators, at least one, you actually get a functioning Bitcoin bridge that has much better trust assumptions than anything we have right now in production. And this is my, I promised the previous one was the most technical one. This is how it actually works, this is a tad bit higher level of the actual Bitcoin transactions that you're creating. So there's a lot of Bitcoin transactions, they're all connected with funny connector outputs and spending conditions, and there's the BitVM paper, so my co-founder Alexei, he's one of the authors of this BitVM paper. The BitVM paper, the BitVM 2 paper is very well written, I think. So you can go through it, how like BitVM works and how you construct a bridge with it. And yeah, this is kind of the transaction graph under the hood, you know. When we treated this whole thing as like a BitVM program, like this is actually how it looks if you implement it on Bitcoin. Cool. So very last part that I want to talk about, Bitcoin finality. This is a very quick one. So one big problem in BitVM, right? We said we want to make sure that Bob is actually finalized. Why do we need Babylon? Why not? Why isn't Ethereum consensus good enough? Ethereum has so much, like, while it's smaller than Bitcoin, it's very, very secure. Well, Bitcoin is not very light client friendly. So in BitVM, we need light client proofs, and if you try to build a light client for Ethereum, it's really hard. You need to usually work around with a sync committee, but then you don't really get full Ethereum security. So we need something that's deterministic for BitVM. And, well, we're a Bitcoin project, so might as well align with Babylon and use a solution that works well for us. So in Babylon, you have Bitcoin stakers, so they stake Bitcoin on Bitcoin. And then they can delegate the stake to these finality providers, and the finality providers, they have now bunch of Bitcoin like behind them, and they can finalize the blockchain. And then you get like a very pretty much standard Tendermint style consensus protocol, deterministic, very easy to verify in a BitVM program, much easier than Ethereum consensus. And I think Babylon has like $6 billion worth of Bitcoin right now. Yeah. And yeah, that's pretty much good enough for us right now. Cool. So if we bring it all together, right? So you have Bob, Hybrid L2. You finalize the Bob blocks. You get finality through Bitcoin staking. You get safety through ZK proof. So when you settle the bridges to Ethereum, you need to use a ZK proof that the Bob blocks were produced correctly. You don't trust the finality providers to do that job. You need the ZK proof. You need to verify on Ethereum that Bob blocks are produced correctly. And the same for the BitVM bridge. You need the ZK proof for safety, and you need the Babylon validators for finality. That means Babylon can only cause liveness failures, and the rest is all done via ZK proofs. Okay, and wrapping up, so the idea, what we're trying to do is basically, okay, we have our little roll-up here in the middle, the L2. You have all this complicated Bitcoin stuff, but then really, if you're building an app or whatever chain you have, we give you access to Bitcoin. So if you're an app on Base, we are very happy to provide Bitcoin access to you. If you want to build a new app that wants to have Bitcoin security and direct access to that stuff, go deploy it on Bob. You're in good company. We have Uniswap, we have Euler, and a few others on our chain. But also, if you're somewhere on another chain already deployed, we can probably help you. We're on mainnet since 1 year. We're like 280 mil of on-chain TVL right now. Yeah, and some of the rankings, like we have a bunch of projects. You can just Google us. So yeah. Very happy to talk if you are interested in either BitVM or finality stuff, or want to deploy your next Bitcoin app. And oh yeah, last thing I wanted to mention is we have this BitVM Accelerate organization. So if you're very interested in BitVM and you didn't get scared by my presentation on it, we have a bunch of people that we work with on BitVM. It's a big lift to actually make this a reality. There's a lot of organizations involved, so if you want to be part of that, also please reach out. We are always happy to chat to more people. Yeah, and that's it. Thank you very much.
So we have like time for 1 or 2 questions, and please try to be precise. Thank you.
Thanks for your talk. When you say FPs can finalize Bob, what does it mean with regards to the fact that the OP chain has a 7-day where it can revert, and same for the fraud proof? I don't know what the window is for a native BTC pay in, pay out.
Yeah, this is a modification we're doing to OP stack. So basically, yeah, OP stack has standard 7 days. That's just to get in the fraud proof in time. But the fraud proof in standard OP stack takes a bunch of transactions. That's why they need a long kind of timeout. Our fraud proof is going to be ZK proof. So it's just one transaction basically, which instantly finalizes it. So our current timeout, or once we have it on mainnet, is probably going to be around 18 hours. That's determined by the Babylon, Bob being checkpointed via Babylon on Bitcoin. And we're waiting for 100 Bitcoin confirmations, and that's about 18 hours. So finality delay is going to be a lot lower. Yeah. Thank you.
So one last question.
Yeah, thank you for the talk. I have 2 questions. One of them is splitting into 4 megabyte of blocks. ZK snark, Bitcoin scripts cannot verify altogether, as you said. At that moment, this means we need to rely your service, right, to be able to verify. It's not going to be verified in a decentralized manner. That's going to be one question. The second is about the disputes. So if there are 3 let's say, frauds or 4 frauds at the same time. So it's going to be like 40 minutes because of every block is going to be confirmed 40 blocks. In ZK rollup or optimistic rollup, it's going to be just much quicker than this one. Is this the drawback of Bitcoin or your service? That's it. Thank you.
Yeah, for the first question, the cool thing with BitVMs, we can actually do this with this trick of splitting up the verifier. We can verify the ZK proof right now on Bitcoin without any forks. It's just expensive. But it's possible.
But it's going to be verified externally.
No, it's verified on Bitcoin. It's verified directly. The splitter of this proof, you actually verify it on Bitcoin itself. Yeah, the proof verification is done on Bitcoin itself. Yeah, and then if you have multiple faults, basically, and violations, yeah, you just basically in this operator construction, you just need to provide like one fault proof that shows that the operator was cheating, and then you consider everything else invalid by this operator. Yeah. Cool, awesome, thank you. I'll be around today, so if you have more questions, feel free to come.